Hi, my name is Kome Kadoya. I am the leader of Team 3157, the Williston Northampton School's robotics team, based in East Hampton, Massachusetts. Nothing has had a greater impact on my life than Vex Robotics. My involvement in Vex for the past 6 years has taught me so many valuable skills that I could not have learned anywhere else, and it has shaped my future. This is why I wanted to share our team's journey to the World Championships and explain how it helped me discover my passion for engineering and robotics. My first experience with Vex came at 7th grade when I gathered a few of my friends to start a robotics club at my middle school in Japan. With only a clawbot, we signed up for the only competition available to teams in Japan, the Asia Pacific Regionals. As you can imagine, most of the teams in this high school regional competition had amazing robots that could accomplish every task in the game quickly and reliably. I was astonished at the amount of complex problem solving that could be done with such a simple set of parts. At this moment, I told myself that one day I would get to the World Championships. Fueled by this new goal, I came back next year with a bigger team, and every day after school for a few months, my team and I designed and created a robot for that year's game, Skyrise. I learned so much about the different kinds of lifting mechanisms and how each one expanded and contracted to fit inside the 18-inch box that the robot had to start in, while also building amazingly tall skyrises. I also started to grasp the basics of programming in Robot C, and although we failed miserably due to our motors overheating at competition, I learned a valuable lesson in understanding the strength and limitations of our hardware, and the importance of consistency and reliability. My first 2 years involved in Vex was enough for me to decide on engineering as my future profession, and the experience set me up very well when I came into the US to attend high school. As the high school I attended just switched from FRC to Vex, my first year there, I was able to help introduce everyone on the team to Vex. This was also the first year I started to use CAD software, which I found to be a far better way of communicating robot designs compared to simple drawings. We found that making virtual designs and making changes in CAD would be a valuable tool, as we didn't have to physically build or cut anything, and we could easily revert back if we didn't like a change we made. Although the robot we took to competition had been a big improvement compared to last year, it was still not enough to qualify us for the Southern New England Regionals, the first step in getting to the World Championships. One of the most valuable things I have learned from Vex, however, is that I love solving problems with solutions that involve both hardware and software. I came to this realization in the following year's game, Starstruck, where stars and cubes had to get carried over a fence to the opponent's side. The solution our team ended up with was a grabber with 3 prongs where the 2 outer arms would be powered. The only way I knew how to program this mechanism was to have the motors be continually powered while the objects were being grabbed. Without that, the objects would fall. This, however, meant that the motors would overheat during the matches, as they were trying to move in a direction they could not move in. Here, I learned the crucial programming concepts of closed-loop systems like PID, which allowed me to set an angle for where I wanted the arm to be, and the motor would dynamically adjust to provide just enough power to keep the arm at said angle. This allowed the motors to stay operational for much longer, and this PID controller, combined with our unique hardware, allowed us to accomplish something not many other teams could do: the double cube grab.
We got 2 at once! I want to see 2 cubes at once! Oh my god, we're going to see 2 cubes at once! Are we going to see it? We're going to see it! Oh my god! That is great! Oh, no.
This year, for the first time, we had become tournament champions in a qualifier match, which allowed us to advance to the Southern New England Regionals, and although we didn't qualify for Worlds there, we had our first taste of success. Being part of a Vex team had allowed me to understand what specifically about engineering had interested me. Although I had looked into majoring in mechanical engineering, electrical engineering, or computer science, I realized that I had done a little bit of everything in my Vex career, and I wanted to learn more about all of them. There is no clearer example of this than in my junior year, when our team used a combination of hardware, sensors, and software to tackle the challenges that the game provided. That year's game, In the Zone, involved stacking cones onto mobile goals, which could be scored into zones in the corners of the field. During the 15-second autonomous period, I used sensors like the touch, encoder, ultrasonic, and line tracking to ensure that the motion of the robot during this period would be reliable. Also, combining encoders, PID loops, and multi-threaded execution of our program allowed our driver to hold down one button while the robot would automatically create a stack of 11 cones. Working on this robot was so rewarding as I saw that utilizing concepts from all three of the aforementioned majors had allowed me to solve this problem in such an elegant way. This year, when we again qualified for the Southern New England Regionals, we got to ally with teams that had regularly qualified for the Worlds. I ended up hearing stories about the amazing experience of being with 18,000 other students who had worked on the same problems you have for the last few months. I was again determined to make it to Worlds before I graduated. With the goal of creating a team that could consistently get to Worlds, how I ran the team in my senior year changed. From creating different teams, some of which were dedicated to qualifying, while others were dedicated to passing down the knowledge to younger students, to making sure we had a clear strategy for getting to Worlds, we made several changes and I learned so many skills that would allow me to run and be part of engineering teams far more effectively. This year the team was given a new lab to work in, which allowed students to spend more time on the robot. This, combined with our more ambitious goal, meant that we needed to keep track of which tasks had to be completed, who was working on them, and if the tasks were progressing at a good pace. For this, we created a Gantt chart and started an electronic engineering notebook. These tools allowed us to keep our ultimate goal in mind as we delved deep into the hardware and software. This would be a perfect story if we qualified for the World Championships at this year's Southern New England Regionals, which will be held on March 16 and 17. However, whether we qualify or not, I still got so much from being part of the Vex Robotics competitions. Vex has helped me understand that rather than being confined to one field of study, a major like robotics at WPI will allow me to utilize mechanical engineering, electrical engineering, and computer science concepts to more effectively solve problems. And although the plethora of technical knowledge I have learned will be indispensable as I study to become an engineer, there are so many skills Vex has taught me that no class could ever teach. Planning out long-term projects, convincing others of the importance of your cause, motivating teammates, and persevering through challenging tasks and failure are all skills I developed because I was part of 3157. I am so grateful that I was given this opportunity, and I know that these skills will be a crucial part of my future. Thank you.